Sure, I hope you're doing well. My name is Shirin Ali, and this is the file for the assignment 3. First, we started by importing the necessary libraries required for our project. We use Keras for building and training the model, and matplotlib.pyplot for plotting the results. And the TensorFlow package is used for the deep learning operations, while to categorical from Keras helps in converting labels into one hot coded format. We also import the necessary layer for our neural network, including conv2D, max polling, 2D, and dense. And finally, we imported Cepher 10 dataset, which will serve as our dataset for training and testing. So next we loaded the Cepher 10 dataset using the Cepher 10 load data function. This function automatically splits the dataset into training and testing data, and then in this step we perform one hot encoding on the labels using the to categorical function. This function converts the integer labels into binary matrix, which each matrix corresponds to a class in the Cepher 10 dataset. The one hot coding is essential for multi-class classification task, ensuring that the model understands how to categorize each input images. And then to make sure that models works efficiently, we convert the image pixel values from integer to floating points numbers, and then after converting the pixel values to float, which we normalize the image by dividing the pixel values by 255. And then here we define the model using keras.sequential. This model began with the convolutional layer with 32 filter and a kernel size of 3x3, and then once the model architecture is defined, we compile the model by specifying the optimizer, loss function, and evaluation metric. We use the Adam optimizer, which is efficient and widely used. The loss function is appropriate for multi-class classification, and we track accuracy as the metric to evaluate the model's performance. And then here to monitor the model's performance during training, I created a custom callback. The callback logs the accuracy for both training and validation data at the end of every fifth epoch. This allows us to keep track of the model's improvement and make adjustments if needed. And then here we train the model using the fed function, specifying the training images, labels, and other parameters. And once the training is complete, we use the result plotting function to visualize the accuracy curves for both training and validation data. This allows us to see how the model is performing and whether it is overfitting or generalizing well. And that's the result. And this is some questions that I answered for this assignment. And in here, in question number 6, we add more convolutional layers to the model to see how it affects performance. I added another conv2D layer with 128 filters, and a time 3 times 3 kernel followed by a max pooling layer. This makes the model more complex and may help improve its performance. And yeah, this was all the codes for assignment 3. Thank you so much for watching.